My name is Caitlyn Robinson, and today I will be going over the RADaR project. Cybersecurity threats are constantly evolving, and new threats are discovered every day. Zero-day exploits are new cybersecurity threats that have not been patched yet. Even though these threats have not been patched yet, they're still being talked about on social media platforms. These exploits are especially dangerous to small organizations that lack the resources to keep up with these new and ever-changing threats. Larger companies and organizations do have resources that they can use to dedicate to specialized teams that can find and mitigate these issues. Smaller organizations and businesses do not have this luxury. This is where RADaR comes in. RADaR is able to take information gathered from social media platforms like Twitter, now known as X, and Reddit. This data is pulled to create a customized dashboard that provides businesses with summaries of threats. This dashboard will also provide users with links to posts that provide additional information about a threat and possible remediation. This helps to fill in some of those gaps that will be left thanks to the lack of that specialized cybersecurity team. In this slide, you can see a few examples of the types of posts that will be pulled from Twitter. We can gather some valuable information from these posts. You can see here that the threat is a remote code execution type threat. We can't expect the typical small business owner to know exactly what a remote code execution attack is, so if they need additional information, they can click the links provided to other posts for more information. Here from posts, we can see that the vulnerability is affecting Microsoft Exchange. This post tells us exactly what's happening with this vulnerability. It says the vulnerability gives an elevation of privilege in Microsoft Exchange. But again, a small business user may not know what this means, but in that case, they may want to refer to the other linked post for clarification. Here are a few examples of what some of the Reddit posts look like. Here we can clearly see that the Reddit posts are much longer and provide more information than tweets because of the increased character limit on the platform. Users may want to refer to linked tweets for a summary of a thread, and to linked Reddit posts for more detailed information or clarification. The Reddit posts provide much of the same information that the tweets did, but here we can see that this post also shows users what they can possibly do to mitigate the threat. This is what the summary page of the dashboard looks like. The dashboard shows users the name of the threat, the date it was first reported, the threat type, which will tell some basic information about a threat, like if it's a Trojan, ransomware, malware, or some other threat type, and a risk score, which is calculated based on how many posts are made about a threat, and if people are talking positively or negatively about that threat. Keep in mind that positive posts or a low risk score can simply indicate something like that the situation is improving, not that it is no longer a threat. This section, Current Risk Trend, shows whether your risk score is increasing, decreasing, or staying the same. This visual, named Threat Summary, places threats based on current risk score and average post sentiment. Darker dots show that more posts are being made about a threat. This visual helps to give users an idea of where to look first. Threats with low sentiment, high risk, and many posts should be looked at before others, as these threats may pose more of a risk than others. Users may click on any threat name or any threat present in the visual to get to this page and have a more detailed look at that threat. On this page, you can see the threat name, the date that threat was first reported, the current risk score, the threat type, a summary that gives a detailed explanation of that threat, an activity summary that provides users with detailed visuals, a visual that shows past risk scores, with red being high risk scores and green being low risk scores, a visual that summarizes average post sentiment over time, where each line represents another social media source, a post count visual that displays the number of posts made about a threat each day on each social media, which, like the sentiment visual, shows each source as a different line. A related post section that links to posts about the threat. This section is broken into posts that are about mitigation, and posts about the threat that just provide more information. It's also broken up by posts from Reddit and Twitter. This section shows a list of any possible information and systems that may be compromised by that threat. This is the pipeline used to get all of the necessary data. First, data is taken from Twitter and or Reddit using those platforms' own API. Posts about threats are then filtered out and go into the Bronze database. Data from the Bronze database is taken by GPT-4 to create things like the summary, determine a threat name and type, determine if a post is about mitigation or not, and more. Data also undergoes any necessary transformations. A couple examples of the transformations include things like making sure that all dates are in the same format, and changing things such as the column names in each source API's default to something else so that it all matches in the gold database. One example of this is changing the tweet column from the Twitter API to a post text column. And the final clean data is stored in the gold database. After it's stored in gold, data is finally ready to be displayed onto the dashboard. In conclusion, many small businesses are at risk of falling victim to new and emerging cybersecurity threats, but RADaR can help these businesses by providing them with the information necessary to protect themselves and to take action by providing them with information about new threats. This includes names, summaries, risk scores, links to information on mitigation, and much more. And finally, I'd like to thank some of the people who helped to make this project possible. I'd like to thank the Commonwealth Cyber Initiative for helping to fund this project, especially the Southwest Virginia CCI node and Gretchen Matthews, who is the Southwest Virginia node director, and Michelle Hall, who is the Chief Administrative Officer and Program Manager. I would like to thank CTE Workforce, who I have been working with to create this project, and to work towards making RADaR an actual product that is more than just a capstone project. I'd specifically like to thank Bobby Keener, the CEO at CTE Workforce, for acting as my mentor during this project, and Seth Wallach, a software developer who helped in the development of things like the API implementation and the ChatGPT implementation. And finally, I'd like to thank Bill Cramer, a business analyst and process engineer at Virginia Commonwealth University, who also served as one of my mentors on this project.